video is going to discuss how we sometimes end up with a biased sample. So as we said previously, the goal of research is to generalize from the sample to the population. So to do that, we need a representative sample or a sample that mirrors the population. So we want characteristics in the sample that are similar to or mirrors those of a population. So what would you call a sample that isn't representative? Biased. So a biased sample, basically the sample characteristics don't equal or are not similar to the population characteristics. Some of the individuals in the sample may be older, faster, smarter, have a different education. There can be differences that we're able to see and differences that we're not able to see. For example, let's say we had a population that was 80% male and 20% female. That's our population of interest. And we select a sample and we end up with 50% male and female. Now, is this sample representative of the population? No, it's biased in some way. It's unrepresentative. So it is a biased sample. So where does this bias come from? Well, one part of the bias can just be from random bad luck chance, right? There's random differences in the population, and then when you select your sample, you just randomly get a sample that's not representative. There also can be selection bias or sampling bias. And this is when participants or subjects are selected in a manner that increases the probability of obtaining a biased sample. So what we're going to do in a later video is talk about the ways that you select your sample to avoid this selection bias or sampling bias. And there also is some things you can do to try to prevent biased samples. In addition to wanting to use these sampling techniques that we're going to talk about in a later video, there's also something called the law of large numbers. Now, I'm going to simplify it here. In statistics, you might learn a little bit more in detail about this, but basically what we're talking about for the aspects of this class is that as a sample size gets larger, that sample mean is closer to the population mean. And if the sample mean is close to the population mean, that means that your sample is representative. So a large sample is going to be more representative than a small sample. And our target sample size is around 25 to 30 individuals. And that's because it's been shown that the average difference between a sample mean and a population mean, it decreases. So that's the difference between the sample mean and the population mean decreases as the sample gets larger. But if you notice here, it's kind of exponentially increasing until we get to around 25 participants. And so this is the number of scores in the sample. And so that's why we say between 25 and 30 is going to give us a fairly representative sample. And when we get much larger, we don't really get a sample mean that's more representative of that population mean. So, and there's other factors that can come into play when you use really large samples.